So hello everyone. So today we are gonna explain the numerical. We are gonna discuss the numerical. So what is given in the question? Can compute the minimum side distance required to avoid a head-on collision of two buses approaching from the opposite direction. The speed of the both the buses is 70 km per hour. Both buses have the same speed, assuming a total perception and brake reaction time of 2.5 seconds. That is the total reaction time. Coefficient of friction equals to 0.4 and brake efficiency is 50%. So we know that this is the two lane. Okay, my vehicle is moving right here, another vehicle is moving from this direction. So I need to calculate the minimum side distance, that is stopping side distance. Okay, so what will be the SSD? SSD will be, we know that 0.78 into V into T, that is lag distance plus B square by 254 into F plus minus N into eta. What is N? Gradient is given? No. Gradient is equals to 0. What is efficiency? Efficiency is 50%. So what will be the efficiency? 0.5. Okay. So on keeping the value 278 into velocities, both are moving with the same velocity, that is 70 into, both will have the reaction time at 2.5 plus 70 square divided by 254 into what is F. F is given as 0.4 plus minus what is N. What will be the value of N? 0 into efficiency 0.5. On solving this, we get 145.1 meter. So this is a two-lane road. That's why it will be covering 145 meter from here. I'll be covering 145.1 meter from here. So total SSD equals to 2 into 145.1 and it will be 290.2 meter. All right. This was the question. And next question is calculate the stopping side distance for the design of 60 km per hour in a two-way traffic lane, in a two-way traffic in two-lane road, two-way traffic in a single lane road. So two-way traffic in a two-lane road and two-way traffic in a single lane road. Okay. Uh, I'm sorry. I think in this is in two lane, but the question is saying that the collision of the bus approaching from the opposite direction. Okay. So I think this would be like this. The vehicle will be approaching from here and another vehicle will be approaching from here. So the total distance will be I'll be covering 145 right here, and and then the vehicle will be covering 145 right here. So our stopping side distance is 2 times 145. But in double lane road, I won't be covering any. I'll be covering like this distance because we are in opposite direction. So our SSD will be same. In double lane, we don't have to multiply it by 2. Okay. Because you'll be coming right here and I'll be coming right here. We are in opposite direction, so there won't be head of collision. But if the vehicle will be in here, I can stop the vehicle by moving up to a distance of SST. Okay, so that's why I think in double lane road we don't have to multiply it by 2. So what will be the calculate the safe stopping distance for the design speed of 60. So what is given as B equals to 60. We assume reaction time of the driver to be 2.5 seconds and coefficient of friction at 0.35. We need to assume, okay, you have to remember this formula, and SSD will be 0.278 into B is equals to 60 into 2.5 plus B square will be 60 square divided by 254 into 0.35. Gradient is also not given. We assume the brake efficiency to be 100%, that is 1. So we will be doing like this, and the value will be 82.82 meter. So SSD in double two-way traffic will be same as 82.2 meter that I explained earlier, and in same direction will be SSD will be 2 times 82.2. Okay, that is 164.4 meter. So the next question is the driver of a vehicle traveling at up a grade required 9 meter less to stop after he applies the brake that the driver traveling at the same initial speed down the same grade if the coefficient of friction. So while the driver is moving in upstream, he required 9 meter less SSD to stop after he applies the brake than the driver. So SSD minus 9, this in upstream will be equals to SSD in downstream. Okay. So what will be the vehicle traveling in the downgrade? SSD in downgrade. Downgrade SSD will be 0.278 will be cancelled out from here and here as well. Okay, let's we can keep it 0.278 into V into T plus B square. B square by 254 into down. We are the vehicle is moving in downgrade. That's why yan will be negative, because the vehicle is moving against the grade. That's why yan will be negative. So what is given between the coefficient of friction, that is 0.5 minus what is the grade. Grade is given as yan. Grade is not given. Okay, and into brake efficiency assume it as 1. So what will be the SSD in upstream? This is downstream. Okay, so what will be the SSD in upstream or upward moving vehicle? That will be 0.278 into V into T plus B square divided by 254 into 0.5. Now it is moving upward, so plus into 1. So my equation is this, equation 1. So I will keep that in equation 1. So I'll be getting 0.278 into upward. So into V into T plus B square by 254 into 0.5 plus N into 1 minus 9 equals to 0.278 into V into T plus B square by 254 into 0.5 minus 9 into 1. So my this two value will be cancelled out, right? This and this will be cancelled out, and on solving we can keep this equation directly in calculator and we can solve it for the value of yan. The value of yan will be obtained as 0.044, that is 4.4%. Now what is given in the question, what is the percentage grade? We calculated it. And what is the braking distance down the grade? Braking distance down the grade means braking distance will be this. So we keep the value of yan at 0.044 and we calculate this value, and the value will often be as, because this is lag distance and this is braking distance, right? So the braking distance will be, braking distance equals 55.3 meter will be the answer. You can check it out after keeping the value in here. The b velocity of b is given as 80 and yan is we calculated 4.4 and we can solve it. Okay, so the next question is vehicle moving at a speed of 90 km per hour decided to overtake another slow moving vehicle. Okay, calculate the safe. So considering two-lane road with two-way traffic. So two-way traffic means the vehicle will be coming in opposite direction as well. The C vehicle will be there. And in second case, two-lane with one-way traffic. So one-way traffic means both the vehicles are moving in this direction, right? So there is no C vehicle. So there will be no D3. In second case, there will be no D3. Okay. So we can calculate it. So how we calculate? Let's do this. So in first case, we need to calculate the D1. D1 is the reaction time of me. I'm considering me as a overtaking vehicle. Okay. So I'm this is a slow moving vehicle. So this is slow moving vehicle. That is B. So no. This will be A. This is B. My this condition is when I'm fast moving, then in D time I stop. I reduces my velocity and become my velocity as, and my I make my velocity as the velocity of the B vehicle. That is B vehicle is this, and in this case my velocity will be BV, and now I'm overtaking. Okay. So D1 will, what will be the D1? What will be the value of D1? So what will be the value of D1? D1 will be 0.278 into BV into T. So 0.278 into what is BB? This is the design speed, right? We haven't given the value of BB. So what is value of BB? 90 minus 16. I have explained it, right? But be careful, this is 16 kilometer per hour. If the question is given in meter per second, then you need to convert this 16 as well. The 16 in meter per second will be around 4 or 3.5 something. So please do that accordingly. Okay, please don't be careful in this question. So what will be the value? It will be 74. 90 minus 16 is 74, and into what is reaction time? 2.5. If not given, then you can keep it as 2, but I think here it is given. Look here, reaction time is 2.5 seconds, so keep it according to the question. And what will be the value of d1? It will be 51.43 meter. And what will be the spacing? Spacing is given by the empirical formula, right? That is 0.69 into BB plus 6.1. The BB is in meter per second. So we need to convert this meter per second into kilometer. That is 0.278 into BB will be 74 in plus 6.1. So plus 6.1. So what will be the value? 20.29 meter. Spacing will be 20.29 meter. Now we need to calculate the overtaking time. Let's do this in this portion. So overtaking time t equals to under root of 4s by a. But a is given in kilometer per hour. You can look here. A is given in 2.5 kilometer per hour, right? So I convert this as 4.4 s divided by a. So what is the value of s? The value of s we computed as 20.29. So into 20.29 divided by what is a? A we computed given as 2.5. So 2.5. So its value will be around 10.81 second. So d2 distance equals to 0.278 into BB into t plus 2s. So 0.278, this is the distance covered by the velocity b. 10.81 plus 2 into 20.29, the value would be 262.96 meter. Okay, now d3, what will be the d3 distance? So d3 distance equals to velocity of design velocity, that is 278 into what is given by design velocity is given as 90 into 10.81. So it is the time covered by me, that is me, I am the overtaking vehicle. So what t is the time taken by the overtaking vehicle to overtake the slow moving vehicle. Okay, so the value is 270.47. So OSD for first case means 2 lane with 2-way traffic. So we need to consider the d3 as well. So d1 plus d2 plus d3, so the value is 585 meter. And OSD plus second case will be d1 plus d2, and the value will be 350 meter. So like this the question is done, and let's move on to the next question. The speed of the overtaking vehicle and overtaken vehicles are respectively 60 kilometer and 30 kilometer on a two-way traffic if the acceleration of the overtaking vehicle is 3.6 kilometer per hour. This is design speed. Okay, I'm the overtaking vehicle and I'm moving with the design speed, and then I reduce my velocity with the velocity of the slow moving vehicle. Okay, so calculate the safe overtaking side distance and determine the minimum length of the overtaking zone. So what is overtaking zone? Overtaking zone is basically, it is a zone which is provided along the length of the road where the vehicle can overtake. If the road is very narrow, then somewhat the overtaking zone is provided between 3 to 5 times of overtaking side distance. The distance of the overtaking zone will be 3 to 5 times the overtaking side distance. 3 times overtaking side distance is minimum, and 5 times is normal average. So the vehicle, consider this road is very narrow, and I want to overtake this vehicle, and continuously the vehicle is coming from the opposite direction. So when the slow moving vehicle reach here, I can overtake this vehicle from this overtaking zone. That's why that is called the overtaking zone. Simple, it is an overtaking zone. Okay, so let's solve this question as well. uh, so we'll be solving this question. So what is given? The speed of the overtaking and overtaken vehicles, that is design speed, is given as 60 kilometer per hour, and the velocity of slow moving vehicle is given as 30 km per hour, right? And a value is given as 3.6 km per hour per second. And we need to calculate the safe overtaking side distance. Okay, so how do we calculate? First we need to calculate d1. D1 equals to 0.278 into 30 into reaction time is 2 seconds. Equation we haven't, the question has not given us the reaction time, so we assume it at 2 seconds. We assume reaction time as 2 seconds for the overtaking side distance, but 2.5 seconds for the stopping side distance. All right, so the calculating we get 16.68. And what will be the spacing between the vehicle? It will be 0.69. It is empirical. 30 plus 6.1 will be, it will be 111.85 meter. And the next will be overtaking side distance, that is 14.4 into 11.85 divided by a is 3.6, so the value will be 6.88 second. And d2 equals to 0.278 into vv into t plus 2s. 0.278 into bb is given as 30 and 6.88 plus 2 times 11.85, the value is 81.08 meter. You can do this. Okay, and what will be the value of d3? So d3 equals to 0.278 into b into t. Design speed is given as 60. That means the velocity with which I was moving with 114.76 meter. Simple as that. So what will be the OSD? uh, so OSD will be d1 plus d2 plus d3, that is 98 meter will be the answer. And what will be the overtaking side distance? So overtaking zone will be, overtaking zone will be 3 times the OSD, that is minimum length. Okay, minimum length will be 3 times the OSD. So 3 times what is OSD? It won't come 98. I think it will be 213 meter. So 2 into 213 meter equals to 639 meter will be the distance of the overtaking zone. So look here, this is for the, I think our question has asked about calculate the safe overtaking side distance, 1 or 2. So okay, it's okay. So like this wise we can calculate the value of the overtaking zone. And now in the next portion we'll be studying about the setback. Okay, we'll be explaining the setback distance. We'll be learning about the setback distance. Thank you for today.